3 sections. The first section is designed to familiarize you with the technical innovations and new design features of the CBX. The second section is designed to familiarize you with the proper servicing procedures and basic engine configurations. The third section will demonstrate disassembly and reassembly highlights. The CBX is an ultra-smooth 6-cylinder, 6-carburetor, 24-valve, double overhead camshaft, 1047cc engine that produces over 100 horsepower. Honda proudly introduces the CBX, the no-nonsense, ultimate high-performance motorcycle for the experienced rider. This machine is the most sophisticated motorcycle on the market today. The engine is a masterpiece of technical innovations. Its sophistication is not new or experimental to Honda. It's been developed and proven on the racetrack. Contributing to the CBX's performance is a specially designed airbox which feeds 6 28mm CV carburetors. The carburetors are tucked in out of the rider's way thanks to the V configuration carburetor assembly. The airbox is tuned to compensate for the unequal length intake manifold. Instant throttle response is provided by 6 CV carburetors and an accelerator pump which injects extra fuel when the throttle is opened. CV carburetors reduce the effort required to turn the throttle. The 24 valves are directly actuated by overhead camshafts. The camshafts are driven by 2 separate heavy-duty silent automotive-type cam chains. 4 valves per cylinder, 2 intake and 2 exhaust, are incorporated into a pent-roof combustion chamber for maximum efficiency. 2 valves have more port area than the conventional single-valve arrangement. Also, the smaller valves weigh less, so valve float is minimized. An over-square cylinder design with a bore of 64.5 millimeters and shorter stroke of 53.4 millimeters reduces piston speed and stress. The over-square 6-cylinder CBX engine, with its advanced valve train, is the most sophisticated production motorcycle engine on the market today. Firepower for the spark plugs comes from a specially designed solid-state pointless ignition system that's practically maintenance-free. The alternator rotor is rotated by a friction coupling that slips under hard acceleration to protect the alternator. The CBX is truly an experienced rider's machine that demands your undivided attention. Never before has such a sophisticated, high-performance motorcycle been available to the experienced street rider. The backbone of this high-performance machine is a diamond configuration frame which utilizes the engine for extra stiffness, reducing flex to a minimum. This type of frame also increases ground clearance and makes engine removal easier. To absorb small road irregularities, the front forks have specially designed low-friction bushings beneath the seals and an ingenious dual taper at the bottom of the stanchion tubes to reduce static friction. Dual-rate fork springs make the CBX at home on smooth streets or bumpy roads. FVQ rear shocks with Honda's 2-stage rebound damping help keep the rear wheel under control. Precise and reliable tapered roller bearings support the steering head. A pair of Honda's new lightweight disc brake calipers up front and one at the rear haul the CBX down from speed at an amazing rate. All aluminum Comstar wheels carry tubeless tires with a tread pattern specially designed for the CBX. Even with its 6-cylinder engine, the The CBX has incredible cornering clearance thanks to ingenious engineering. The ignition system and alternator, which are normally located on the ends of the crankshaft, are mounted on a primary shaft behind the engine to make its overall width within millimeters of the CB750. Also, the outermost crankshaft counterweights on number 1 and number 6 cylinders have been reduced in size to allow beveling of the lower crankcase for even more ground clearance. The highly efficient 6-into-2 exhaust system tucks up and out of the way. To keep the CBX as light as possible, the countershaft sprocket cover, alternator housing, alternator cover, and oil pickup housing are made of magnesium alloy. In addition, lightweight aluminum is used in the Comstar wheels, foot peg plate, front and rear foot pegs, gearshift lever, brake pedal, and of course the engine. To match the CBX's performance, a 60-watt quartz halogen headlight cuts through the night to light the way. Now that we've shown you some of the CBX's technical features, let's see what the magazines have to say about this unique new motorcycle. Cycle magazine says, the CBX is an immensely flattering bike with perfect elegance and total class, and history will rank it with those rare and precious motorcycles which will never, ever be forgotten. Cycle World says, if anything, the rumors were understatements. Cycle News says, the Honda CBX is the most exciting street motorcycle ever. Motorcyclist magazine says, you are witnessing the ultimate street machine, one that incorporates all your wildest dreams and then literally surpasses them. Cycle magazine says, the bike is more than fast. It is magic. The exploding glitter of its technical credentials lights up the sky. Honda, going strong. This section of the program is designed to familiarize you with the proper servicing procedures and basic engine configuration for the CBX. The following subjects will be covered in this section: the valve train, the cam chain tensioner, the ignition system, the charging system, the fuel system, the emission control system, power flow, and the lubrication system. The valve train system. For maximum breathing efficiency, the CBX uses 24 valves and dual overhead camshafts. Shim-type adjusters are used to reduce weight and to simplify the valve system. The camshaft lobes rotate on the shims, which are held by cup-type valve lifters. The valve lifter then depresses the valve. To change the valve clearance, you replace the shim with one of a different thickness. The engine should be rotated by using the 17mm nut machined onto the right end of the crankshaft. To gain access to the crankshaft nut, you must first remove its cover held by 3 screws. The valve should be checked and adjusted when the engine is cold, which is below 95 degrees Fahrenheit. Before the cylinder head cover can be removed, the tachometer cable should be disconnected. Then, remove the tachometer gear cap and driven gear. Caution: if the tachometer driven gear is not removed, damage will result to these components. The gas tank, number 1 and number 6 spark plugs, and then the cylinder head brackets must be removed. Caution: number 1 and number 6 spark plugs should be reinstalled before removing the head cover to prevent engine oil from entering the combustion chamber after the cover is removed. To check the valve clearance, refer to the service manual or the backside of the full cycle valve adjustment worksheet for the proper sequence. This sequence will reduce the time required to check all 24 valves, because 6 valves can be checked without rotating the engine. Only 2 revolutions of the crankshaft are required to check all 24 valve clearances. If for some reason you're not using the valve adjustment sequence, the crankshaft should be rotated so that the camshaft lobe is directly away from the shim. Then, a feeler gauge may be inserted between the camshaft and the shim. You start the clearance check by rotating the crankshaft until the exhaust valves for cylinder number 2 are at their maximum opening, according to the valve adjustment sequence found on the back of the full cycle valve adjustment worksheet. With the engine in this position, Check the valve clearance on number 2 intake valves, number 1 exhaust valves, and number 3 exhaust valves. The clearances should then be recorded on the front side of the worksheet in their respective places. The sheet is laid out similar to the engine. There's a place for 2 exhaust valves and 2 intake valves in their approximate location as found in the engine. The sequence should be followed until all the valve clearances have been recorded on the front side of the sheet. You should strive for a clearance of 0.08 of a millimeter. However, the allowable tolerances for both intake and exhaust valves is 0.06 of a millimeter to 0.13 of a millimeter. Compare the correct clearance with the recorded clearance and determine which valves need to have their clearances adjusted. Use the Honda valve lifter holder to hold the lifter down so that the shims can be removed from the cylinder head. The camshaft has a specially machined surface to support the tool for each set of valves. Refer to your worksheet for the valves that need adjustment. Rotate the engine until these camshaft lobes are pointed away from the shim. Rotate the valve lifter until the notch is positioned so that you can use a screwdriver to pop the shim out. Then, you rotate the crankshaft until the valves that you want to adjust are fully opened. You should then insert the tool under the camshaft and center it on the machined surface. The tool handle should always be facing toward the spark plugs for all valves. Caution: if the opposite pair of valves is opened while the special tool is installed, the valves could be bent or damaged. Make sure you're rotating the crankshaft in the proper direction, or a simple valve adjustment could become a major repair job. Rotate the camshaft so that the camshaft lobes move away from the tool handle, and the camshaft lobe is pointed directly opposite the shim. The tool is designed so that both valves are held open at the same time. If the tool is not positioned properly, it may only contact one valve lifter. If this should happen, it should be removed and repositioned. It's also possible that a slight misalignment can cause the tool to contact the shim instead of the lifter, which would make it impossible to remove the shim. Carefully inspect the tool position before trying to remove the shim. A screwdriver should be used to lift the shim out of the lifter. Then it can be removed with a pair of tweezers. Use a micrometer to measure the center portion of the shim where the camshaft contacts it and record its size on the white section of the worksheet. You now have the clearance and the present shim size recorded on the worksheet. To determine the proper shim size, refer to your valve shim selection chart on the back side of your full-cycle valve adjustment worksheet. First, find the clearance you've recorded on the left column in the blue section. Then, you find the present shim size in the white section. The point where the clearance and present shim size cross in the red section is the replacement size shim you should install. It's a good idea to record the replacement shim size on your worksheet and check its actual size using the micrometer before installing. After installing the replacement shim, rotate the camshaft lobe away from the tool handle until the valves are once again at maximum opening. Then, remove the special tool and rotate the crankshaft 2 to 3 revolutions and recheck the valve clearance. Remember to always rotate the camshaft lobe away from the special tool handle as shown here. The procedure for removing and installing a replacement shim is the same for all the valves. The CBX is a 6-cylinder, 6-carburetor, 24-valve, double overhead camshaft, 1047 cc powerhouse that produces over 100 horsepower. It is the fastest, most sophisticated motorcycle on the market today. Proper valve adjustment is essential for maximum power and reliability. The full-cycle valve adjustment worksheet can reduce adjustment time and help you keep a record for that special customer. Cam chain adjustment. The CBX incorporates 2 separate heavy-duty multi-plate silent-type cam chains, each with its own separate tensioner. To adjust the cam chain tensioners, start the engine and allow the CBX to idle. While the machine is idling, Loosen the cam chain tensioner lock nut located under the carburetors in the cylinder, 1/2 turn. Wait a few seconds and then retighten the lock nut. To adjust the top cam chain tensioner, loosen the lock nut and then the tensioner bolt located in the cylinder between number 3 and number 4 exhaust pipes, 1/2 turn. Wait a few seconds and then retighten the tensioner bolt and lock nut. The cam chains are now adjusted. The ignition system. The CBX uses a specially designed transistorized ignition system that requires a minimum of maintenance. The system is amazingly simple, considering it fires 6 spark plugs. The system can be compared to a battery and points ignition system, with the pulsar generator and spark unit taking the place of the ignition points assembly. 3 Type 2 ignition coils, similar to other Honda 4-cylinder models, are used. A conventional mechanical advancer is located behind the pulsar generator to advance the ignition timing. The pulsar generator and spark unit act as a solid-state switch, replacing the conventional mechanical points assembly. Current for the 3 ignition coils' primary windings is supplied by the battery, similar to a point-type ignition system. The spark unit controls the ground for the ignition coil's primary windings, similar to a battery point ignition system. The pulsar generator signals the spark control unit when to interrupt the ground, causing the magnetic field surrounding the windings to collapse. This fires the spark plug, just like opening a set of points. The pulsar generator is driven off the right side of the primary shaft. The ignition system can be divided basically into 3 systems. Each system fires 2 spark plugs at the same time. When the tooth protruding from the rotor passes the metal core tooth of the pulsar coil, an electrical signal is sent to the spark unit to fire the spark plugs. Here is the rotor tooth lined up with cylinder number 1 and number 6's pulsar coil's metal core tooth. Located at 2 o'clock is the pulsar coil for number 2 and number 5 cylinders. At 6 o'clock is the pulsar coil for number 3 and 4 cylinders. The solid-state, no-maintenance spark unit is located under the battery box. The 3 ignition coils are located under the fuel tank. The ignition coil for number 1 and number 6 cylinders is located on the left. Number 3 and number 4 cylinders coil is in the center. The coil for number 2 and number 5 is located on the right. The ignition system on the CBX should never need adjustment because there are no points to wear out. However, the timing can be verified using the following procedure. Rotate the engine until the F mark on the crankshaft aligns with the front mating surfaces of the crankcase. The timing marks on the crankshaft should not be checked with a timing light when the engine is running, because oil will run out of the engine and damage will result. The timing is correct if the tooth on the rotor and the protruding tooth on number 1 and number 6 pulsar coil line up as shown here. If they don't, loosen the 3 locking screws and rotate the backing plate until they line up, and then retighten the locking screws. If you feel there's a performance problem related to ignition timing, the advancer mechanism can be checked by using the Honda special degree wheel. After the F-mark timing has been checked, the procedure is as follows. Remove the pulsar generator cover. Also remove the rotor bolt and install the special degree wheel. Align the rotor tooth with the triangle and then retighten the rotor bolt. Connect a timing light to number 6 spark plug high-tension lead, and then start the engine. The spark advancer is working properly when the 23.5 degree mark lines up with the rotor tooth between 2,000 and 2,500 RPMs, and the 31 degree mark lines up at 6,400 to 8,000 RPMs. Caution, do not allow the engine speed to go over 8,000 RPMs, or engine damage can result. The charging system. The CBX incorporates a heavy-duty 3-phase alternator driven off the left side of the primary shaft by a friction coupling. A solid-state combination rectifier and regulator unit is located under the battery box. The electromagnetic field rotor is connected to the voltage regulator by a set of brushes and slip rings. the regulator controls the output of the charging system by varying the amount of voltage it supplies to the electromagnetic field rotor. The rotor rotates inside the stator windings to produce electrical current. The alternator rotor is driven by a friction coupling consisting of two steel discs pressed against each other by a spring. The friction coupling will slip to protect the alternator rotor from damage. The fuel system. The CBX uses 6 28mm constant velocity carburetors to feed air and fuel to the engine. An accelerator pump and air cutoff valve combine with the CV-type carburetors to give the CBX instant throttle response throughout the entire RPM range. The CBX CV-type carburetors have a 3-jet fuel system similar to those of the CX500 and the Hawk. The slow fuel jet found under the black plug is pressed in and is not removable. This is not a negative feature because careful testing has been done to ensure drivability. The accelerator pump is housed in the number 3 carburetor's float chamber. When the throttle is rotated quickly, the pump rod is depressed, causing the pump diaphragm to push fuel into all 6 carburetor venturis. Fuel for the accelerator pump comes from the number 3 float bowl. Each carburetor has its own check valve and nozzle. The check valve stops the fuel from draining out of the fuel passage. The accelerator pump linkage is operated by the throttle pulley. When the throttle pulley is rotated, the linkage rod is pulled upward. The pump arm then pushes the pump rod downward to inject fuel into all 6 carburetors. Check the service manual for the adjustment procedure. The air cutoff valve for all 6 carburetors is incorporated into the number 1 carburetor main body. The air cutoff valve prevents backfiring during rapid deceleration. During normal conditions, when intake vacuum is low, air for all 6 carburetor slow fuel jets is supplied by the air cutoff valve. Air is drawn from number 1 carburetor from under the vacuum piston and through the air cutoff valve to all the carburetors through the air pipe passage shown here. When high vacuum occurs during rapid deceleration, the air cutoff valve stops the flow of air to the carburetors, which richens the mixture. Idle speed adjustment for all 6 carburetors is simplified by using only 1 throttle stop screw, which is located under the fuel tank on the right side. After the motorcycle has been driven 10 minutes, the engine idle speed should be set. Turn the throttle stop adjustment screw until 900 RPMs, plus or minus 100, is obtained. Carburetor synchronization. The number 4 carburetor is the master carburetor, and all other carburetors should be synchronized to it. It's important that you synchronize the carburetors in the proper sequence, or you could spend a lot of time wasting your time. The rule of thumb is to start at the carburetors closest to the master carburetor and work outward. We'll assume you'll be using the standard Honda 4-vacuum gauge set. Before the carburetors can be synchronized, the idle speed should be set at 900 RPMs, plus or minus 100. Then, hook the number 4 carburetor to the gauge on the far right so that you'll remember to synchronize all carburetors to it. Hook number 3 carburetor next to number 4, and then number 2, and then number 1. Step number 1 is to synchronize number 3 carburetor to number 4 carburetor using the Honda special carburetor throttle wrench. Rotate the screw located in between number 3 and number 4 carburetors until the vacuum gauges are within 1.6 inches of mercury. Step 2 is to synchronize number 2 carburetor to number 4 carburetor using the carburetor throttle wrench. Synchronize number 1 carburetor to number 4 carburetor using the carburetor throttle wrench. Synchronization is correct when the vacuum gauges read within 1.6 inches of mercury. Hook the number 4 carburetor up to the second vacuum gauge on the left, similar to how it would be on the motorcycle. Next, connect number 5 and then number 6 as shown. Step number 4, synchronize the number 5 carburetor to the number 4 carburetor using the carburetor throttle wrench until the vacuum gauges are within 1.6 inches of mercury. The 5th and final synchronization step is to synchronize number 6 carburetor to the number 4 master carburetor using the carburetor throttle wrench. The pilot screws are preset at the factory and should not be readjusted by the dealership unless the carburetors have been overhauled or someone has misadjusted the pilot screw. If they must be readjusted, consult the service manual for the correct procedure. The CBX is equipped with a closed crankcase system to prevent emissions from entering the atmosphere. Blow-by gases and oil vapors are routed to the air cleaner assembly. The liquids are separated and collected in the storage tank. The gases and vapors are routed back into the engine to be reburned. The drain tube should be emptied every 3,750 miles, or sooner if liquid is visible in the transparent tube between the air cleaner assembly and storage tank. To gain access to the air cleaner element, the seat and then the air cleaner inlet duct must be removed. Remove the air cleaner set spring and the air cleaner element from the housing. The foam air cleaner element should then be carefully slipped off the screen element retainer. The element should be washed in non-flammable solvent. After it's been cleaned, the excess solvent should be squeezed out and the element left to dry. After drying, the element should be soaked in 80-90 weight gear oil, and then the excess oil should be squeezed out. Carefully reinstall the element onto its retainer and install into the machine. Shown here is the power flow starting at the crankshaft. Power is transmitted from the crankshaft to the primary shaft by a heavy-duty multi-plate chain. The primary shaft drives the alternator off its left side through the friction coupling. The right side drives the clutch by the use of straight-cut gears. The clutch transfers the power to the transmission main shaft and then to the transmission countershaft. The countershaft drives the countershaft sprocket and then the heavy-duty number 630 rear drive chain. The lubrication system. The CBX uses 2 oil pumps to supply oil to the engine components. The main pump supplies oil to the oil filter, cylinder head, pistons, and crankshaft. The auxiliary oil pump feeds oil to the oil cooler, primary shaft tensioner, transmission shaft, and countershaft. The proper primary drive chain tension is maintained by an oil pressure activated tensioner assembly. The oil pressure forces the chain tensioner guide against the chain to maintain the proper tension. Caution: even though they appear to be the same, the CBX oil filter element has a higher flow rate capacity than other models. The oil filter element is not interchangeable. Disassembly and reassembly highlights. In this short section, we'll demonstrate the correct procedures for removing and reinstalling the camshafts. We'll also demonstrate the procedure for timing the primary shaft to the crankshaft. Remove the cylinder head cover, camshaft oil pool plates, oil delivery pipes, and cam chain guide. The camshafts ride in 16 bearings. Each bearing holder has a number and an arrow cast onto it that should be pointed forward to ensure correct assembly. Camshaft holders number 4, 5, 12, and 13 should now be removed. Both cam chains must have no tension on them, or the camshaft sprockets cannot be removed. Loosen the front cam chain tensioner lock nut and tensioner bolt. Using a tool, depress the cam chain where it contacts the tensioner blade to reduce the chain tension. Then, tighten the lock bolt and lock nut. Loosen the rear chain tensioner lock nut and pull the tensioner up to reduce the chain tension, and then retighten the lock nut. After the cam chain's tension has been removed, rotate the crankshaft so that the T-mark lines up with the forward crankcase mating surfaces. Make sure the camshaft lobes for number 1 cylinder are facing the spark plugs. If they don't, rotate the engine 360 degrees until they do. The intake camshaft and exhaust camshaft are actually 2 separate camshafts joined by a special Oldham coupler. Remove the 3 remaining camshaft holders retaining the left intake camshaft and the 3 holders retaining the left exhaust camshaft. Then remove the camshafts and couplers. The camshaft has identifying marks stamped onto it next to the bearing in between number 1 and number 2 cylinders. Turn the crankshaft 1 full revolution and realign the T mark with the crankcase mating surfaces. And the number 6 camshaft lobes should now face the number 6 spark plug. Remove the 3 remaining holders retaining the intake camshaft, and then slip the camshaft out of the cam chain and remove the camshaft from the cylinder head. To remove the remaining exhaust camshaft, rotate the camshaft until the sprocket retaining bolts can be removed. Then, remove the remaining camshaft holders and camshaft. The sprocket can now be slipped out of the cam chain. You now have access to all the valve shims and lifters. The lifters are designed to rotate in the cylinder bores. Therefore, the lifter bore in the cylinder head is a precision bearing surface. When using a spring compressor to remove the valves, the special protector tool should be used to protect the bearing surfaces. Make sure that when removing the lifters, you mark them so they're replaced in their original position, or problems could result. To reinstall the camshafts, coat all the bearing surfaces with molybdenum disulfide grease, and then rotate the crankshaft until the T aligns with the crankcase mating surfaces. Place both cam chains over the sprocket, with the punch marks on the sprocket aligned with the head cover mating surfaces. Position the exhaust camshaft in the cylinder head with the number 6 camshaft lobes facing the spark plug. Install the securing bolt and tighten by hand loosely. Install holders number 6, 7, and 8. After the holders have been torqued using a crisscross pattern, torque the sprocket bolt. Then rotate the engine and install the remaining sprocket bolt and torque. Rotate the crankshaft until the T aligns at the crankcase mating surfaces, and the dots on the exhaust camshaft sprocket are aligned with the head cover gasket surface. Also, the number 6 camshaft lobes must face the spark plug. Then install the intake camshaft and sprocket with its dots aligned with the head cover gasket surface, and number 6 camshaft lobes facing the spark plug. Install camshaft holders number 14, 15, and 16. Rotate the crankshaft 1 full revolution until the T mark realigns with the crankcase mating surfaces. Install the couplers, and then install the intake and exhaust camshafts with their number 1 cylinder lobes facing the spark plug. Install the remaining holders and torque in a crisscross pattern. Install the oil pool plates. Fill the oil pockets surrounding the lifters and shims with oil. Don't forget to adjust the cam chain tension. The carburetor's cylinder head and cylinder can be removed without removing the engine from the frame. However, before they can be removed, the engine must be tilted forward. Remove the front engine hanger brackets, rear hanger brackets, and the rear upper mounting bolts. This will allow the engine to be tilted forward. Before the cylinder head can be pulled off the cylinder, the cam chain tensioner bolt must be removed. The bolt is located at the rear of the cylinder above the cam chain adjuster nut. When reinstalling the crankshaft and primary shaft, they must be timed to each other, because the primary shaft controls the ignition system. The crankshaft and primary shaft timing is correct when the T on the crankshaft aligns with the crankcase mating surface, and the dots on the primary driven gear are 90 degrees from the crankcase mating surface, as shown here. Install the primary shaft into the primary driven gear with its notch facing upward to match the dot on the gear, which is 90 degrees from the crankcase mating surface. The CBX is the most technically advanced motorcycle on the market today. Experienced mechanics will appreciate its engineering and respect its intricacy. Proper servicing is essential for maximum performance and reliability.